Hello, everyone. This is Mr. Kim speaking. I'm from Riverside Virtual School. I'm a Math 2 teacher. Uh, I'm recording this video to go over this conjecture called longest side, largest angle conjecture. All right, so let's dig in. All right, so let's look at this guy here. First of all, let's do a little bit of recap. Uh, Through the Khan Academy videos, two Khan Academy videos, you folks cover two things so far, right? Triangle sum theorem and triangle inequality conjecture. So this was mainly about angles of a triangle, where you have three interior angles. When you add all of them, they will equal to 180 degrees, regardless of what type of triangle we're talking about. It could be scalene, it could be right triangle, it could be isosceles triangle. Regardless of what shape of triangle it is, the angles, interior angles, their measures will add up to 180 degrees. Right. And then you folks also learned something called triangle inequality conjecture. Uh, Contrast to theorem, which was proven in Khan Academy, as you have seen or you have watched, triangle inequality conjecture was not proved mathematically, but so far we'll accept it as true. Okay, so what this was saying was the length of a side of a triangle is less than the sum of the lengths of the other two sides of a triangle. So just pick any side of triangle. It will be always less than the sum of other two sides here, or the lengths of the other two sides. And this is just a fancy way of writing that down over there. We'll revisit this later on. And the third concept that we're learning is called longest side, largest angle conjecture. So conjecture is a guess, right? So it's still not proven with this observations that was looking into some of the triangles, uh, but we'll accept it as true. There is a full proof on it, actually, but we'll not go over it for this stage of the course. Right. So it's simple actually. So if you look at it, all it's saying the conjecture is with the triangle, the longest side is always the opposite of the largest interior angle. And I should probably say of the triangle, of a given triangle. Nah. Yeah. So longest side is corresponding to the opposite of the largest interior angle, and vice versa. And you'll see from the example in a second. And second thing that we can talk about from this first statement is that if one side of a triangle is longer than another, then we know that the angle opposite the longer side is greater than the angle opposite the shorter side, and also vice versa. Okay, so let's go over two examples. They'll show us what's going on. So if we assume this is true, with the given angles, for example, we have angle ABC here, right? Uh, Triangle ABC, that is. With the triangle ABC, you can actually see which is, or you can find out which is the longest side just looking at the angle using longest side, largest angle conjecture. So how do you know? So let me try to color code here. First of all, I want to see which angle has the largest measure. And you see, 70 degree, right? So it looks like that is the largest one. So it's a measure of angle. See, right? And the second largest angle will be this guy here, interior angle of the triangle. That is, angle B is 58 degrees. So I'm just writing this in order, by the way. So measure angle C and the measure of the angle B, right? And then last but not, last and least, actually, in this case, is angle A. So you have measure of angle A. So if I write down the magnitude, it will be the measure will be 70 degree here. There'll be 58 degree, and then 52 degrees. So, and here we can write down our inequality symbol saying that measure of angle C is greater than measure of angle B is greater than measure of angle A. So it is in descending order, as you can see. Okay, so based on this, Mr. Kim, there's no length given for each of the sides. But how do we know if which one's the longest side? Well, using the longest side largest angle conjecture, what you folks will do is the longest side is always the opposite of the largest interior angle of a given triangle. So if we assume that is true, this is the largest interior angle of this given triangle, right? 70 degrees. And what you're actually going to be saying is opposite of this angle C, right, which is going to be segment AB or side AB. If you find the length of that, so this is length of segment AB, that is going to be your longest side. Okay. And what do you think comes next? Yes, it should be corresponding to angle B. So opposite of angle B, which is going to be AC, comes next. So that's the next longest side. And the shortest side, the last place, is going to be, and you folks see that arrows that I'm matching up, right? So opposite of 50 degree will be BC, right? Segment BC or side BC. And it goes in that order as well. Do I see actual length of it? Nope, but I can determine from the angle size which one goes from longest to shortest. Okay. Then we can actually check it out too. Let's see. I did have something. You know what? Let's revisit that later. I thought I had it, but it's fine. Okay. Let's go to the next one here. Okay, now not angles given, but the length is given, right? So 7.3 units, 9.7 units, and then 11 point units. Each of the lengths are given. And then can you determine what is the largest angle? And yes, you may. Even though we do not have measures the angles here, but we can actually determine. So here, let's see which one is the longest side. And you'll see, 11.8. That's the longest side. So I'm going to say ED is 11.8 units. It will be the longest side. What comes next? It will be FD, right? So FT comes next, which is going to be 9.7 units. Cool. And then the last place for our length is going to be EF or FE, doesn't matter, right? And then that'll be 7.3 units. All right, so this is in descending order, very similar to what we did over here. Only difference is here measure of angles were given, and here the length is given on the sides. And based on this, we can determine which has a largest angle, and that is going to be opposite of this side here is going to be measure angle F. All right, measure of the angle F will be the largest angle. And then the next one is going to be opposite of side FT. So that we measure of angle E. And there's the last one that's it's going to be opposite of the shortest side 7.3 will be the smallest angle, which will be angle D in this case. Do I know the measures of the angles? I don't. But based on the descending order of the sides here, right? ED is the longest and then EF is shortest. I can see that my largest angle will be F, and then smallest angle will be D. Oh, here I forgot to write down the measure. So measure of angle D. Right. So that's pretty much it for the longest side and largest angle conjecture. And I said I was going to show you one thing from let's see, give me a second on this. All right, so I was able to find it. So it should be CPM similarity here. So let's take a look at it. Yeah, so this was the very first example triangle, right, where you had a 70, 58, and 52. And guess what? If you look at the side, the opposite of 70 degree, which is AB, 7.8, it gives us the longest side right there, right? And then next one comes opposite of 58, which is 7. Then opposite of 52, which is the smallest angle, will give us the shortest side right there. And guess what? This works for any triangle, doesn't matter. Like, let's say I create something like this. You see that's the largest angle, 119 degree. And that's the longest side, which is the opposite of the largest angle. And the shortest side is 4.3, you see? And then there'll be 24 degree, which is the smallest angle. Just be careful though, it's not proportional though. When you're trying to determine the angle measure here, it's not proportional to the ratio of the sides of the longest side to the shortest side. Okay. Only thing we know is which one's the largest angle, and the descending order of angles or sides depending on what is given to you. Right. So that concludes this lesson here. The question will be given to you to answer the question, regarding the longest side, largest angle conjecture. Okay. And make sure you do review all these three theorems or conjectures together, because it's useful when you're dealing with sides and angles of a triangle. Okay. All right, folks. Have a good day and peace.